Hello, dear students. Greetings of the day. I, Muhammad Zishan, welcome you to the online classes of Blooming Birds Code School Sambal. Dear students, today we are going to have the second lecture of chapter 3, which is rotation and revolution. So, in last chapter, I have told you about the characteristics of rotation of Earth. In that chapter, I told you about the direction of rotation of the earth and its speed as well as its inclination of axis. In this chapter, sorry, in this lecture, we are going to study about the effects of rotation. Effects of rotation. What are the effects of rotation? When the earth rotates, then what happens? That thing we are going to rotation, sorry. Effects of rotation, right? When the earth rotates, then what happens? So the first observation which we have is of occurrence of day and night. So the first effect of rotation is occurrence of day and night. So how day and night takes place? Suppose this is the earth, right? And from here, here's the position of sun. Clear? So the part which will be facing sun will experience or observe day, and the part which is not facing the sun will experience or observe night. So here this one part, okay, this one part, Europe, Africa, and this Europe, this one part will be facing what? uh, Day, and the back one part here, this one part which is behind America, right? This will be in dark. So Earth is rotating from west to east this way, right? And every part of the earth comes in front of sun at a point of time, at some point of time, okay, and that point of time or that duration till until when it remains in front of sun, either directly or it may be receiving the slanting sun rays, okay, that time, that duration will be called day, right? So in a book, it is written, occurrence of day and night are caused by rotation of Earth on its axis. This is because part of the Earth which face the sun have day, and the parts which do not face the sun have night. This happens with precision and progression and not suddenly. The time when the sun begins to cast its light in the sky is known as dawn. At noon, the sun is overhead. At dusk, it is twilight, and the sun is seen disappearing in the sky. At night, it is completely dark. Duration of the day and night is not equal at all places on the earth because of the inclined axis. The length of days varies with respect to the seasons as well as latitudes. So this is written in your book. Let me explain you what does that mean. So here, suppose this is sun, okay, and this part, which was, suppose this part, this country is Mauritania, okay. I'm just giving example of Mauritania. This is the Western African countries, okay. So if suppose it was here behind earlier, so it means that it was not facing sun, and there it was dark or night. So as earth is rotating this way, so at some point of time what will happen, this place will come here. Sun is here, sun is here, and this place is here, okay. So now this place will start receiving diffuse light, okay, because this is earth, and all around earth we are having atmosphere is like, this is the surface of the earth, the land, okay, and from there upside, okay, till uh, thousands of kilometers, we are having our atmosphere. So you can say that this much entire area, right, this much entire area is atmosphere of earth. Now the sun is here, so when sun rays falls, okay, in the sky, right, then what happen, it get diffused. So suppose it is, the atmosphere is still here also, and the sun rays are falling here on the atmosphere and sky, skies, okay, and clouds also, clear. So what will happen, this will be reflected to these places also, here and here, right, and these places will also get sun rays slantingly or diffuse light, okay. So when this place will be this much here, so now this place will start experiencing the diffused and scattered light of the sun, and that period, okay, which comes after the dark or night, okay, is called dawn. Subh Sadiq, clear. So that is called dawn, right? And the earth keep rotating, right? Then after some time, what happened, the sun appears to rise, okay, although the, after 5 minutes, huh? After half an hour, huh? Let me complete this, okay. Then what happens, uh, so this earth keep rotating, and when it comes in front of sun this way, right, so then we see sun rising from the east. So you wake up early in the morning at 5 o'clock, right, then there is light, but sun is not there. Sun rises after 1 hour, right, so that much time is called dawn, okay, the time period when we have scattered light or diffuse light, right, and then afterwards the sun will start appearing from the from rising from the east, and then what will happen, this earth will keep rotating, and then it will come directly in front of the sun. Now here this will experience noon. Why? Because sun rays will fall directly, okay, sun rays will be perpendicular to this place, clear. So here it will be noon, and then afterwards it will keep rotating, okay, then what will happen, then it will move this side, okay, this side. Now here the sun will appear to set, okay, and one time will come when sun will set in the sky, okay, sun will not be visible, but still you will be having light, okay. So that time is called dusk. When the sun is setting, that time is called dusk, right, and when it has set completely, right, then what, then still you have light. So that period is called twilight, okay, the period of maghrib, okay, when the maghrib azan takes place, okay, that time is called twilight, okay. So after twilight what will happen, then you will not observe light, you will not have light, okay, you will stop receiving even the diffuse light, and you will, that place will move this direction here, and the night time will begin, okay. Then again this cycle will keep takes place, okay. So here when the sun is rising, that time is called dawn, right, and when the place is in front of the sun and sun rays are perpendicular to a particular place, okay, then that is called noon. And when the sun appears to set, right, then that time is called dusk, right, and dusk is also called twilight, okay. The twilight is a time when the sun is has set completely, right, but still light is there, okay, and dark approaches slowly, right, till until it becomes completely dark. That time period is called twilight. So that was about the occurrence of day and night. Now sunrise and sunset. What is sunrise and sunset? Acha, now this duration of day and night varies, okay. Duration of day and night varies when the north pole is inclined towards the sun, right, then the duration of day will be longer in the northern areas, okay, north pole areas, and the duration of days will be shorter in the South pole. But here, what is here? You can see that south pole is inclined towards the sun. So here the days will be longer in the southern hemisphere and nights will be longer in the uh, northern hemisphere. Clear? And also when you move from equator towards pole, the duration of day will keep increasing. The duration of day will keep increasing, and at some point of time, okay, for 3 months this entire circle, okay, will remain in constant daylight. Okay, likewise when the earth will revolve like this and its position will be this way, this way. Now the north pole is inclined towards the sun, right? And the areas which are uh, in the northern hemisphere will experience more daylight. Duration of daylight will be more, and the duration will keep increasing as we move from equator to towards pole. Why? Because this polar region is inclined towards the sun, and this area receive continuous sunlight, okay, for at least 3 hours, right? So that was about the duration of days and nights. Now we will study the next thing, which is sunrise and sunset are caused by, the second effect is sunrise and sunset, which I have already told you. Sunrise and sunset. Okay, so this is earth, clear, and this is western hemisphere, this is eastern hemisphere, and earth is rotating this way from west to east. Okay, so then sun is stationary. So when you are moving from one direction and something is in stationary position, then that stationary thing will appear to move in opposite direction. Like you move in a bus, right? Then the trees on the sides of road appear to move in the opposite direction you are moving. So likewise, you are moving from west to east. Earth is rotating from west to east. So sun will appear to rise from east to west or move from east to west. Clear? So here we are having sunrise and sunset are caused by a rotation of earth from west to east. Okay, I have already told you rotation is from west to east. Earth is rotating this way. This way from west to east. Clear? And this happens because due to the earth's rotation, every part of earth's surface faces the sun at some time or the other. The parts of the earth that moves from darkness into the sun rays experience sunrise, and when it moves away from the sun rays it experiences sunset. Okay, so that I have already told you. This is the earth, right, and this is the sun. Clear? And the part of the earth which starts receiving the sun rays, okay, right, that part experience what? Morning, and then the procedure takes place till noon, and then at the evening time, right, it starts it means it comes into, it stops receiving the sun rays. Okay, then that time is called sunset. Sunrise and sunset are caused by rotation of the earth from west to east. This happens because due to the earth's rotation, every part of the earth's surface faces the sun at some time or the other. The part of the earth that moves from darkness into the sun rays experience sunrise, and when it moves away from the sun rays it experiences sunset. So it is clear. Now we will study the third thing, which is very very important, that is Coriolis effect. This you need to understand properly. Coriolis effect. So Coriolis effect was given by G. Coriolis. G. Coriolis was a geographer or a scientist, you can say. Right. Now, what is this Coriolis effect? Coriolis effect, you will have to understand it by recalling the things which I have told you in lecture first. In lecture first, I told you that Earth rotates like this, right? And the speed of Earth rotation is higher at the center, right? The speed of rotation is maximum at the center, and whereas the speed of Earth's rotation keep decreasing towards the pole, right? So this area is moving faster than this area, and this area is moving faster than this area. Okay, so you can say as you are moving towards pole, the rotational speed is decreasing, right? Rotational speed is decreasing, so this area is moving very fast. Now this area is moving very fast from which direction to which direction? From west to east. Okay, from west to east. Clear? So if some water current, okay, or something is moving from equator towards the pole, this direction, right? So it here what will happen, that particular object or thing or water or air, right, will be experiencing this rotational motion also, right? And that rotational motion or that force will be higher at this place and lower at this place, because here the rotational speed is higher. Clear? So when it is having the force is higher here, so that force will pull that body which is moving towards the north this side. Okay, as it will move this side, so it is moving this way. Here one object is moving this way, trying to move this way, right? But actually it moves this way. Why it is getting deflected towards it, right? Because here at this place, when this object was here, it was having or it was experiencing more rotational force or speed, okay, right, then at this place. So here you are having more speed, here you are having less speed. Okay, so what will happen? So when you will try to move this way, you will also, means one force you are applying in this direction and another force of Earth's rotational motion is in this direction. Clear? In this direction. So the result will be this. Okay, so this is called Coriolis effect. So what is Coriolis effect? This is Earth, this is equator, northern hemisphere, southern hemisphere, west and east. Earth is rotating from west to east in this manner, right? Here speed of rotation at these places, okay, will be higher. We have already studied in first lecture. In your book it is given speed on page number 24. The speed of Earth rotation at the equator is 1670 kilometer per hour. The speed decreases towards the pole. The speed is decreasing towards the pole. So here, suppose if one object is here at this place, right, and that object is experiencing a force, okay, which is moving in this direction. Clear? In the towards the east, okay, moving towards east, but actually that object wants to move towards north, right? Then what will happen? He is applying force to move towards north, but this geographical rotational force is forcing that body to move towards east also. So the resultant motion will be this, right? This is called Coriolis effect, right? So what is Coriolis effect? Any object which is moving towards north pole from equator, right, get deflected towards it right hand side. This is right, okay, right hand side of the movement, right? I am moving this way. Clear? This is my right hand side. So that is called Coriolis effect. That object is getting deflected towards its right in the northern hemisphere and towards its left in the southern hemisphere. How? Here it is having this region, this area of or place of the earth will be having this part of the earth is moving faster than this part of the earth, right? Rotational speed is higher here, okay, and here rotational speed is decreasing. So if one object is moving, right, from equator towards pole this way, okay, trying to move this way, clear, but still we know that, okay, earth is rotating this way, okay, right, and one force is applied on that this way also. So that what will happen, the resultant direction will be this, right, clear. So now a person or not a person means water or air is moving in the southern direction this way, right, this way, but getting deflected this way towards the left hand side. This is left hand side, okay, so this is left hand side, right, L. This is called Coriolis effect. This effect is called Coriolis effect. And why Coriolis effect is taking place? Because of the variation in the rotational speed of earth at its different parts. At this part, which is at the center, the rotational speed is higher than this part, okay, and it is least at the poles. Rotational speed of the earth is least at the poles. The speed of rotation of the earth is decreasing, right, from equator towards poles, because of that only, okay, because earth is rotating this way from east to west, and that force is being applied, okay, we all are on earth and we are experiencing that force, okay. So when a water flows or air mass flow, right, so that the get deflected, okay, towards its right hand side and left hand side in the northern hemisphere and the southern hemisphere respectively, and that effect is just because of the rotational variations in the rotational speed of the earth, and that is called Coriolis effect. I hope you would have understood that. Now sometimes it is also called that clockwise motion in the northern hemisphere. Why? Because clock moves this way. If it is here, then it will be here, then here, then here, okay, like this. So here also what is happening, some object is moving this way, okay, or getting deflected this way, and here object is getting deflected which way, this way. If it is trying to move here but going there, this way, clear. So this is anti-clockwise and this is clockwise, clear. Now next thing is, let me check video how it is going on. 23 minutes, just 3 topics. Now next is the sun, the moon and the stars seem to move from east to west, okay, that's why, because the earth is moving from west to east. The sun, the moon and the stars appears to move from east to west. Why? Because earth is rotating from west to east. This is west, this is west and this is east, okay. So earth is rotating this way from west to east, clear. So when earth is rotating from west to east and we are here in India, right, clear, and sun is here, so we were here earlier, this is the eastern part of India and this is the western part of India. I have marked here W and E, clear. I know that I am in Sambal here and I know this is east direction, this is west direction, clear, and earth was India was in dark, okay, and here it was sun. So when earth keep rotating from west to east, then the part of India which are in the eastern sides will will observe sun first. Okay, clear? So now when I will look, okay, at the sky, then what will happen? I will find sun in the east direction from Sambal, right? And it will keep moving, right? Keep moving. And then I'll keep moving like this, and sun is here only. Sun is going nowhere. Okay, then it will appear to me that the sun is setting in the west. Why it is happening? Because the earth is rotating from west to east, and sun is appearing to move in opposite direction, that is from east to west. Clear? So this is the reason, right, why these sun, stars as well as moon appears to move from east to west. This is because the earth spins from west to east. This effect is similar to what one experiences while looking at trees from the moving train, that I have already told you. Now, centrifugal force is also experienced. Okay, what is centrifugal force? Right, you must have seen a lattu moving this way, right here. Clear? The force which applies on it outside, okay, that force is called centrifugal force. Centrifugal force is on every rotating body, right, and it is towards the outward motion, right? If earth is rotating like this, if earth is rotating this way, then one force will be acting on it towards its outer sides, okay, and that is called centrifugal force. Because of the centrifugal force only, when earth is rotating this way, right, what happens? The earth bulges out from the center here, because the speed of rotation is higher at the center, so it bulges out. Okay, it bulges out from the center and it got flattened from the top, right? That is the reason why the earth is bulged at the center, because of its center, because of the centrifugal force being applied on earth. So what is centrifugal force? It is an apparent outward force that acts on a rotating object, on every rotating object, whether it is a lattu or whether it is a earth. It is always directed outward, that is away from the axis of rotation. The speed of earth, the speed of rotation has created a centrifugal force, resulting in a bulge in the middle portion of the earth and flattened top at the poles, that I have already told you. Now the next effect comes about, that effect is rotation causes difference in time over. Okay, rotation causes difference in time over. Fifth was centrifugal force. Why centrifugal force? Because of the rotational movement. Centrifugal force is observed because of the rotational movement. Okay, then sixth is rotation cause difference in time. Okay, difference in time, right? Now what is the difference in time? See, we know that, okay, earth rotates, earth completes its one rotation of 360-degree, right, in 24 hours. Clear? So we can easily say that, okay, in earth rotate by 1 degree in just 4 minutes. Okay, so there will be difference of 4 minutes on every line of longitude. We are having 360 lines of longitudes. Okay, so when you multiply 360 by 4, right, you will get 24 hours. It means that, okay, these 360 lines of longitudes comes in front of sun one by one and keep coming. Okay, right, like suppose if this is a line of a longitude, I am just writing here this one line of longitude, this point, right? So suppose if it is here, so it will keep moving, and when it will come in front of sun, if it will come this way, when it is getting diffuse light, then it will experience morning, and when it will be in front of sun and will be receiving light, sun rays perpendicular to it, okay, then what will happen? Here it will be noon, then it will keep moving this way, okay, then it will experience evening, and then it will experience night. Okay, so like this, one by one, every line of longitude, okay, every line of longitude is what it is signifying. It is signifying the part of the earth, okay, vertically from north pole to south pole, right, those parts will come in front of sun one by one and will observe the point of time, okay, either it is morning, right, or it is 10 o'clock, or it is noon or afternoon or evening, and a twilight, okay, and the dark, okay. So there is a difference of 4 minutes on every line of longitude. I have already told you in chapter number 2, if you remember. And if you don't remember, then you can watch that video again, right? Then rotation causes difference in time over various places on the earth. Difference in time is 4 minutes for each degree of longitude. 24 hours is equals to 1440 minutes divided by 360 degree. Then you will get how many minutes? 4 minutes. Okay, so there will be a difference of 4 minutes on every line of longitude. Then the side of the earth towards the sun constantly gains heat, and the side away from the sun constantly loses heat by radiating it in outer space. In this respect, rotation of the earth is in a tilted position on its axis has the following advantage. The first is the short rotational period makes the variation of temperature between day and night moderate, and rotation in combination with revolution earth's movement around the sun causes seasons and variations in the length of day and night over different places on earth. Now what does that mean? The side, what they are trying to say is that, okay, the duration, right, of rotation is short, and the side of earth which is experiencing sunlight, okay, right, is become that portion or that side of the earth becomes warm, and the side which is opposite, okay, right, this one side, the opposite one side, it becomes cool. Why? Because the heat which was absorbed during the daytime will be reflected back, okay, will be radiated back, okay, that will be called terrestrial radiation, right, and it will be radiated back into the space. Clear? So this way the earth's temperature is maintained, and we human beings need a particular temperature for our existence, okay, normal temperature, right. So that temperature is maintained like this. If the duration of rotation was longer, suppose if it was not 24 hours, suppose it was of 6 months, right, so for 6 months this one region would have faced sun and would have become very hot, okay, and this region would have become very cold, okay, and because of that extreme kind of temperature, we people would not have been people would not have even survived, okay. Clear? So this short duration of rotation helps us or helps in the existence of humankind on the earth, right? Clear? So this rotation of the earth for 24 hours brings every part of the earth in front of the sun and make it warm, and after that it just go behind and becomes cool, okay. The heat energy which was absorbed during day is radiated during the night, radiated back into the space during the night time, okay, and like this the temperature of entire earth is maintained, okay. And earth is rotating, right, this rotation plus the tilt, this tilt, okay, this 66.5 degree inclination towards the sun. Suppose this is sun, right, so this is 66.5 degree angle, okay, right, and the revolution, okay, around the sun, right, these three things are responsible for variations in season, right, that we will study in next lecture, right. Thank you so much.